Alright, just when you thought it couldn't get any more complicated, we have to pretty much add one more step. So, this is going to be example 10.3 for Mr. Eggerse's physical science class out of the book. I'm going to try to explain it the best that I can in hopes that you guys can understand it. And I got faith. I believe you can do it because you guys are awesome. Alright, example 10.3. Page 245. A man needs to push a desk. The mass of the desk is 100 kilograms, and he's got to push it across the floor. The static frictional force can resist motion with as much as 196 newtons of force, while the kinetic frictional force is only 110 newtons. So the difference between these are, we kind of talked about it in class, and I know Jordan wasn't there, so I'll try to explain it really again. Static frictional force is the force whenever something is at rest, or it's not moving, it's not in motion, and that is the force that it takes to move that object. Or static frictional force is the force that acts on objects that are not moving. Kinetic frictional force is the force that, when an object is moving, the resistance that it has on it. So, for example, my cell phone right here, in order for me to get it moving, there's a force that I've got to do on the object to get it to move. That force is the static frictional force. After I get it moving, it's actually easier. It's harder to start it, but then it's a little easier after I get it started. So that force is the kinetic frictional force. I'm still getting resistance. Otherwise, if I stopped my hand, the phone would keep on going, according to Newton's first law. But we do have that force of friction acting on it, which makes it stop. Alright, back to the problem. So, part 1 in the problem, we need to find the force needed to start the moving desk. So, the first question you should be asking yourself, since they give us both static and kinetic, is which one do I use? Because they give us the static frictional force is 196 newtons, and the kinetic frictional force is 110 newtons. So, since it's not moving, it's at rest, then we need to use the static frictional force that's acting on it, which is 196 newtons when it's standing still. And therefore, the force needed to move it is a little bit more than 196 newtons. So that answers the first part of the question. And then part 2, we need to find the actual force, and this is actually a couple different steps. Because in order to do that, in order to find the actual force that the man puts on the object, we got to find the total force first. So to do this, we must first find the total force. Because remember, the total force, first of all, we have the resistance force, but that's at rest. And the second part of the question says, if the desk accelerates at 1.0 meters per second squared to the west when the force is applied, how much force did the man use? So it's when it's moving, so we're actually going to be using a different thing as well, that other force. So let's go ahead and find the total force first. So we write this down. We write down our stuff over here. The mass is 100 kilograms still. The acceleration is 1.0 meters per second squared west. When we do that, we actually get 100 newtons west. It's pretty easy math to do on this one. We don't even have to use a calculator. So this is the total force. Then we go to part 3, where we actually need to calculate the actual force. Now, the force of the man minus the force of friction is equal to the total force. And what we're actually looking for is the force of the man. The force that the man actually puts on the object. So, and that's what the actual force is. The actual force that the man applies to the desk. So we write down what we know. We don't know what the force of the man is. Oh, here's a good question. Kinetic or static? Well, the desk is moving in this part of the problem because it's accelerating. So we're going to use the kinetic force of friction. So we're actually going to be using the kinetic force of friction. The kinetic force of friction in the problem is 110 newtons. That just means that it takes 110 newtons to keep the desk moving after you get it moving. So the force, or the total force, which is what we just found in part 2, I know it's getting a little complicated, but bear with me, is 100 newtons west. So we found that in part 2. So now, the actual force, or the force that the man puts on the desk, minus 110, because they're in opposite directions, the force of the man and the force of friction, is equal to the total force, which is 100 newtons. I did just a little bit of algebra for you, because I know you guys love math. I just added, because I want the force of the man all by itself, or the actual force all by itself. So I got rid of everything on that side except for the force of man. So I added 110 newtons to both sides. So the force of the man is going to be 210 newtons to the west. And I hope that helped out a little bit. Email me if you have any questions on any of these, this problem or the other 2 problems that I've done on YouTube already. All right, thanks. Bye.